Hello students, in today's video we're going to work on areas in the plane. So let's get started. Go ahead and try working on this problem without a calculator. Find the area between the x-axis and the function e to the x from 0 to 2. So to do that we are going to set up our integration from 0 to 2 for e to the x. If you remember, the antiderivative of e to the x is just e to the x. So really we are evaluating e to the x from 0 to 2. And what we're left here with is e to the second power minus e to the 0. That turns out to be e to the second minus 1. And that's it. So in this particular thing, we're going to look for areas between two curves. Now, when we do that, we're literally finding the area in between the two functions. So we'll set up our limit from a to b, keeping in mind that a to b is the intersection of both functions. And then f of x is the function that is above the second equation, g of x. So I know that may not make sense, but we will talk about it with the next example. So again, we're trying to find the enclosed region. And in order for us to do that, we're going to find the points of intersection and then integrate between those 2 points. So let's look at an example now. Here we have the area, here we have y equals x squared minus 2 and y equals x. So let's take a look at those graphs, and this is what we have. So what we're trying to do here is we're trying to find the area between these two curves, which is essentially this region right here. Now here you see that where they intersect at x equals -1 and at x equals 2. So you'll also notice that the function, or the line y equals x, is above the parabola, as in, change this, as in this line right here is above the line, or above the curve y equals x squared minus 2. So when we do this, we're going to set up with y equals x above this one right here. So here's what that'll look like. First of all, if we're not sure how to find the points of intersection, we could set those two functions equal to each other. So we'll have x minus 2 equals x. And we're going to subtract x to both sides. We get x squared minus x minus 2 equals 0. Factoring that, we get x minus 2 times x plus 1 equals 0. We get x is equal to -1 and x is equal to 2. These are the 2 points of intersection for our 2 graphs. Now, we're going to integrate from -1 to 2. And the reason why we're doing that is because that's where our 2 intersection points are. Now remember, on the graph, the line y equals x was on top, or above, x minus 2. So we're going to take x and subtract x squared minus 2 from the whole thing. And since we're integrating with both functions, what we want to make sure we're doing is putting this entire thing in brackets, like so, and putting our dx at the end. And so this is what we have. We're going to be left with x minus x squared plus 2, and we're still including the dx. And then we're integrating that from -1 to 2. And when we do that, our answer turns out to be 4.5. Yes, I did that by hand. You should be able to do that as well. I just wanted to save you some time from seeing all of the math involved. Let's look at another example here. Now we're trying to do the same thing. Y equals x squared equals 2x minus 5. Again, if we wanted to find the points of intersection, we're going to go ahead and do x squared plus 2 equals 2x plus 5. We're going to subtract 2x plus 5 to both sides. We get x squared minus 2x minus 3 equals 0, because 2 minus 5 is negative 3. We're going to factor that. We get x minus 3, x plus 1 equals 0. Get the points of intersection as x equals 3 and x equals negative 1. So now we know where we're integrating. We're integrating from negative 1 to 3. Now, if you're not sure which one goes on top and you don't want to graph it, what you could do is substitute a value in there. So from negative 1 to 3, we're going to pick a value in between. So we're going to go and pick 0 because it's in between. It's an easy number. When we do y equals 0 squared plus 2, we get 2. And when we do that into the second equation, y equals 2 times 2 plus 5, that's going to turn out to be 9. So we know that the 2x plus 5 is above x squared plus 2. Just to confirm that, let's go ahead and graph both. And let's close my email so you don't see that. So if you take a look, our line is above that quadratic. So we're going to go back to doing our thing. So when we integrate now, we're going to integrate 2x plus 5 minus x squared plus 2. Remember, because we're doing the integration, we have to include the dx. We're going to put the entire thing in brackets. And so we're going to integrate this. And because I don't already have the answer, I'm going to go ahead and type this into my calculator really quick. Because yes, the way we set it up can be typed into your calculator. And when you punch that into your calculator, we are going to get 10 2/3. So this is equal to 10 2/3, or 10.67. So hopefully this is getting pretty easy. Let's try another problem. Here we have one problem we're going to do 3 different ways. So looking at example 4 using subregions, what we're going to do is we're going to take this apart and split it into 2 pieces. So to do that, notice how y equals the square root of x comes up that way. And it isn't until x equals 2 where you start running into the line y equals x minus 2. So what we're going to do is we're going to integrate this by 2 regions. So one region is going to be here in red. The second region is going to be here. And this is what it'll look like. So we're going to integrate from 0 to 2 for the square root of x. And the reason why we can do that is because the graph y equals x minus 2 isn't above the x-axis until 2, which is why our upper limit here is 2. Next thing we're going to do is we're going to add the integral from 2 to 4, because that's where they intersect a second time here. Now remember, we want to put the equation that's on top first, and we're going to subtract the lower equation. So we're going to have the square root of x minus the quantity x minus 2 dx. Hopefully you didn't forget to put the brackets. And when we do this, our answer turns out to be 10/3 units squared. We're going to do it another time now. This time we're going to do it integrating with respect to y. So sometimes you'll have these really ugly functions for x, and it's easier to integrate it with respect to y. So we need to be able to convert these. Now, what we're going to do is we're going to first take our functions. So we have first we have y equals the square root of x. And then we're going to square both sides. So we would get y squared equals x. We have y equals x minus 2. We're going to solve for x. We get x is equal to y plus 2. Now we're going to have to convert the limits. So imagine taking this graph and rotating it like so. What you'll notice here is that the graph or the line y equals x minus 2 is on top, just like we've been looking for. Let's keep that in mind. So now what we're going to do is we're going to integrate from 0 to 2, because keep in mind now we're integrating with respect to y. The highest this y value gets is 2, the lowest it was 0. Now when we turned it on its side, we noticed that the graph y equals x minus 2 was on top. So we're going to substitute that in now. So that's going to be y plus 2 minus y squared dy, not dx. We're going to put the brackets. And when you integrate this, you're going to get 10/3 units squared. So make it a point to try solving this and making sure you get 10/3 units squared as well. If you don't, then obviously you made a mistake somewhere and we can fix that in class. So last one, we are going to do the same thing, but now we're going to use geometry. What we know here is that if we integrate from 0 to 4 for the function square root of x, that's going to give us the area from here all the way up to 4. All the way up to 4, so like so. However, we didn't ask for every piece. We wanted everything except from 2 to 4, all the way up to 4, and then back down. So what happens when we do this, we get a triangle like so. So what we're going to do now is we're going to take the area of the whole thing, and we're going to subtract that triangle, which is just 1/2 times base, which is 2, times the height, which is 2. And when we simplify this, we are going to, again, get 10/3 units squared. So hopefully that makes sense. We're going to have plenty of time to try this in class, but that's all for now. I'll see you guys next time.